All right, we are going to talk today a little bit more about logarithmic functions. We're going to talk more about them algebraically than we are graphically. Okay, we talked about graphically on Friday. We are going to practice a whole bunch Tuesday, Wednesday, Thursday, because you guys have a quiz on Friday. I want to make sure we have a good handle on things. So when we talk about two different forms of functions, logarithmic and exponentials, what did I tell you last week these two were of each other? They're opposites. They're inverses, okay? On your calculator, hold on, log, inverse, exponential, right? Okay, they're inverses of each other. On your calculator, the natural log is ln, and the e to the x button, that's an exponential function. They are on the same button because they are inverses of each other. All right, so we're going to practice today rewriting from logarithmic form to exponential and back. It's really important that you guys understand how to do this for the next couple sections that we do with solving. And sometimes it's easier to see things when you rewrite it from one form to another. So the first thing I want to do is I want to bring to your attention the two different forms algebraically. All right, we're not talking about graphs or anything like that, but on the left is your logarithmic function in log form. On the right is your exponential function in exponential form. Do you visually see the difference between the two? Yes. Do you guys see how the log form has the word log in it, right? The exponential form has the variable in the what? Denominator. Not in the denominator, it's in the exponent, right? You see that? So when we're going from one form to another, all we're doing is just switching things. Christian, please put your mask on. Notice, guys, there is a little a in the log form, and there's a big A in the exponential form. Yes? That's basically what we're going to be changing. Little a is going to become the big A, or big A becomes little a, and your x's and your y's switch places. Do you guys see that? Do you see on the left, your a is little, and then if you go to exponential form, it gets bigger. And then your x and y just switch spots. Same thing, if you start with the big exponential form, your a is big. If you go to log, it gets little. All right? You guys see that? So when we talk about switching, all right, obviously this is done for you, but I just want to show you. If you guys are given a problem that says like log base 2 of 8 equals 3, and they want you to go to exponential. When we go from log to exponential, our log goes away. That little 2 becomes what? Big 2 cancels out. And what happens with 8 and 3? They switch spots. So 2 to the third power equals 8. You should be able to look at that and go, does that make sense? 2 to the third power equals 8. Yes. Now some of you might go 2 to the 8th equals 3. You should take a second and go, okay, does 2 to the 8th power, if I multiply 2 by itself 8 times, does that give me 3? No. So then you should be like, oh, wait, I made a mistake. Look at the next example. Log base 2 of 1/8 equals negative 3. When we see fractions, guys, when you see a fraction, you should think negative exponents, or you should also think roots, and we'll talk about that in a second. But if I rewrote this, do you see how the little log 2 became the big one? And then negative 3 and 1/8 switch spots. If you have anything raised to a negative power, what kind of an answer do we always get? A fraction. It's not going to make it negative. It's going to make it a fraction. So just make sure you guys are seeing those types. All right, look here. You're going to be given a problem like log base 2, 32 equals 5. And I'm going to say to you, rewrite this in exponential form. Well, when we do this, the little 2 becomes big 2. My log goes away. And what happens with 32 and 5? They switch spots. Then you can say, does that make sense? 2 to the 5th power, does that equal 32? Yes. Now notice here, in this example, I don't have any negatives, but I have a fraction. If I rewrite log base 16 of 4 equals 1/2, 16 becomes the big base, right? 4 and 1/2 switch spots. What does it mean when you have 16 to the 1/2 power? You're taking the what? The square root, right? What about if I had log base 8 What about if I had log base 8, 2 equals 1/3? Well, let's rewrite this. Let's rewrite this exponentially. My little 8 becomes big 8. And then these two switch spots. This becomes, what is that saying, Pablo?
It's saying that 2 is a third of 8.
Yep, 2 is a third of 8. 2 is the cubed root. What times itself 3 times gives me 8? And it would be 2. A lot of times, guys, especially not now because we're just writing, we're going from one to the other, but when you go and we're solving, it's easier to rewrite in exponential form and then solve. We'll see in a second. Now we're going to learn some special properties here. All right, properties of logs. And this is going to, when you first look at it, you're like, wait a second. This is what? Lots of words and letters. That's okay. After I explain this, you're going to say, oh, can we have a bunch of these on our test or quiz? Let's look at number 1. All right, we're in logarithmic form, right? Let's write this in exponential and see what this is really saying. My little a becomes what? Big A. And then what happens with 1 and 0? They switch spots. So what is this really saying? Anything to the 0 power equals 1, okay? Now, this next one, my little a becomes big A, and then what happens? What do you notice there? It's itself. Do you see how you have log little a and then the same a here? So if you had log base 7 to the 7, what does that equal?
7.
No, what does that equal? 1, right? They cancel each other out. You're just going to have 1. Yeah. Same thing here. Do you see how you have log little a and then your base here? They're the same. What do you think they'll do? They'll cancel out. So if you had like log base 8 of 8 to the negative 4th power, what does that equal? What happens with 8 and log base 8? They cancel, so x equals negative 4. Same thing here. Do you see how you have a as your base and then it's raised to the log a? So if you had 6 to the log 6 of 5 equals what? Well, what happens with 6 log 6? They cancel and x equals 5. All right, these are special properties that after I explain them, you guys are like, oh, can we have like 27 of these, please?
Can you go back to 3?
Can I go back where?
3.
Can you see? Okay, now you can kind of see this with numbers, guys. Log 5 to the 1 equals 0. All right, rewrite this in exponential form so it looks like it makes a little more sense here. Log 5 becomes what if I'm going to exponential form? This becomes a big 5, good. And then what happens with 1 and 0? So 0 equals 1. 5 to the 0 power equals 1. True?
True.
Yes. Do you see here how you have log little 5 and then a big 5? What happens with little 5 and big 5? They cancel, so 8 equals 8. Log 5 of 5 equals 1. They're saying 5 to what power equals 5? Do you see how these are inverses of each other? They just cancel out. They become 1. 5 raised to the log 5 cancels out. So your answer is 12. Do you guys see that? Yes, sir.
What is it?
Yeah. Pablo asked, what if it was like 4 log 5? We'll talk about that later. All right. I talked to you guys last week a lot about exponentials and logarithmics. All right, let's talk about exponentials for a second. Exponential, the domain is always what? Negative infinity to positive infinity. The thing that changes with an exponential function is your range. It's based on the horizontal asymptote. You're going to have 2 different kinds of ranges. It's either going to be negative infinity to the horizontal asymptote or the horizontal asymptote to infinity, right? There's 2 different ones because in our exponential functions, you either have some that are occurring above or below, right? Up or down. That's why it's negative infinity to the asymptote or the asymptote to infinity. And the way you tell that is where the negative is. If you have a function and the negative is out in front, your range is going to be negative infinity to the horizontal asymptote. If you have a function and it's positive out in front, then your range is going to be the horizontal asymptote to infinity. It's just like our parabolas. We talked about that last week. So remember, exponentials and logarithmics are what of each other? Inverses. So instead of the range being the thing that's changing, what's going to change? The domain. For our log functions, guys, your domain is the thing that changes. Your range is going to be negative infinity to positive infinity. Now, instead of looking, y'all, from bottom to top, we're looking from left to right. Your domain is either going to be negative infinity to the vertical asymptote or the vertical asymptote to positive infinity. That's what changes. And the way that you tell that is the negative inside with the x. You'd have a function that says like log negative x plus 1. And then you have a function g of x equals negative log of x plus 1. Where is the reflection that makes a difference in your domain here? Right inside. Your range, your domain here would be negative infinity to the vertical asymptote. In this one, this is positive here, so it would be vertical asymptote to infinity. That will happen every single time. There's only two options for each of them. It's either going to be negative infinity to the asymptote or asymptote to infinity. Those are your two options. All right, does that make sense? Again, we're going to work on this a whole bunch the next couple days just to make sure that we get this nice and ingrained in our brain. Now, same thing, same thing goes for our ln's, our natural logs. A natural log is still a logarithmic function. The opposite of our natural log is e to the x, right? It's on the same button on the calculator. So the natural log of 1 is 0. If I rewrote this, what is the opposite of natural log? E, right? It's on the same button. And then what happens with 0 and 1? They do what? They switch spots. So e to the 0 power is 1. Everybody see that? Okay. What do you notice here? ln and e to the x. They're what of each other again? They're inverses, correct? So what happens here? They just do what? They cancel out. What about here? E to the ln. What happens? Cancels, and that equals x, whatever it is. All right, that's a very, 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 very important thing for you guys to understand, especially when we go into solving, because we're about to go into solving in the next couple sections. And the only thing that is trig related is one step of knowing the inverse to go from log to exponential, exponential to log, and then everything else is just a basic solving of an equation. They're longer, but you guys can do it. All right, again, in your calculator, or if you're looking at this, ln to the e just cancels out. That's where we get 8. Do you notice here that we brought the e up? That's where we got the -2, and then these cancel out. And then ln 5, literally in your calculator, you would hit ln 5, and you would get the decimal equivalent. So you're going to have to do that on some of the problems. Not today, but on some problems. All right, this is from your homework. Right? I have your homework. I don't even know when I have it due. But all it is just rewriting. We're practicing converting from one to the other. So I want to do a couple of these with you just to bring some things to light. First of all, what form am I starting off in? How do I know I'm in exponential form? Because I have an exponent, right? If I go to log, think about it. My big base 8 is going to become my what? My little. Watch how I write this, guys. It's a little 8. Don't write the 8 right next to the G. You don't have to write it in cursive. I just do. I don't know why. But what happens with 3 and 512? They switch spots. So this becomes log 8 of 512 equals 3. That's how you would rewrite that. You're going to have questions on your quiz that just simply says rewrite from one form to another. I'm not going to tell you write the exponential in logarithmic form. You need to understand, oh, I'm starting off in log, I'm going to go to exponential, and vice versa. So here, what are we starting off with? Log. So we're going to exponential. Good. My log base 8 is going to become what? Big 8. Good. And what happens with 2 and 64? 8 squared equals 64. Is that true?
Yes.
Good. Good, good, good. Look at this. So you guys are going to look at this like, what are all these boxes? Guys, the boxes mean nothing. All we're going to do here is go from one form to another. So on the left-hand side, I have log base 9 of 9 equals 1. How would I rewrite that in exponential form? Big 9, and then what happens with 9 and 1? They switch spots. Does 9 to the first power equal 9? Yes. For log base 9 of 729 equals 3. This becomes 9 to the what power? Third power equals 729. Okay? The next two are in exponential, so we need to go to, it's in exponential, we need to go to log. So my big 9 is going to become my little 9, right? And then what happens with 1/2 and 3? They switch spots. Sometimes, guys, it's easy. Literally, draw yourself the little arrow just to give you a little reminder. It's helpful. What's my next one going to look like? Log base 9 of 81 equals 2. Perfect. What about the next one? 9 to the negative 1 power equals 1/9. Good. Very good. Very good. And then what's the next one? Log base 9. 1 over 81 equals negative 2. Good. All right, let's look at these two. What's the opposite of ln? E. So I'm going to replace the ln with an e, and then what happens with 2y and 5? They switch spots. Right? Look at the next one. ln t. You guys are like, whoa, we didn't do this. Yes, we did. What's the, this is very specific. What's the opposite of ln? E. Then what happens with negative 1 and t plus 2? Negative 1 equals t plus 2. Now, what we're going to do later on next week is now we're going to solve this. You don't have to. If I was going to solve this, how would we even begin to do this? Do you guys know how to do e to the negative 1? You can in your calculator, right? You'll get some rando decimal. And then what do you do to get t by itself? Subtract 2. Yep, you're just going to solve basic equations. It's just that one step of knowing that, ooh, the opposite of ln is e. You guys are going to be fine. That's good. All right, these are our lovely. What does log 2 of 2 equal? Just equals 1. What is log 7 of 1? Some of you are like, wait, I don't know that. Well, what's the easiest thing to do in order to see this, to look at it in exponential form? So let's rewrite log 7 of 1 to exponential form. What does 7 become? Big 7. Right? Exponent of, well, 1's going to go to the other side. So what would I have to, good man, what would I have to raise 7 to make it a 1? 0. Right? Your exponent would have to be 0. So when you have log base something of 1, all that's saying is what would you raise that number to make it a 1? It would have to be to the 0 power. And then what happens here? They cancel, so my answer is 5. Good. Let's go through these. Hang on one sec. Go ahead. What's my answer for A?
8.
How'd you get that?
Because they cancel.
Good. What's my answer for B? 28. How'd you get that? They cancel. What's my answer for C? 30. How'd you get that? Perfect. Good job. Okay, let's do these. Did we talk about any with square roots in our exponents? No, does it matter? What are E and ln of each other? So what? They cancel, girls, and it becomes what? Square root of 5. Good. Oh my gosh, should we do any where we had 1 over pi as an exponent? No, but what happens with E and ln? They cancel. My answer is 1 over pi. All right, now we look at this one. You're like, there you go. Always giving us something you didn't teach us how to do. What is the little number next to log?
1, 0,
The little number that's where?
12.
Not the 12. Remember, if I had 10, or let's just say 19 log 19 equals 12, what would my answer be?
12.
Yeah, my answer would be 12. So what do you guys think that little number next to the G is? What's my little base? It's not 1.
10.
It's 10. Whenever you have just the word log, it's assumed, it's understood that it's log base 10. Your calculator is programmed to be in log base 10. Meaning, because Pablo just asked the question a minute ago, if you had like log 6 of 7, what this is saying, right, equals what? If I was going to rewrite this in exponential to try and figure out what they're saying, this would be 6, and then what happens with 7 and x?
The power of x.
So 6 to what power equals 7? Do you guys know that in your head?
No.
No. So this is where we're going to talk about solving, but there's something called the change of base formula, which we'll talk about next week. Most of your calculators do not do a change of base formula. Some of them are already programmed. Some of them have buttons that you can figure out. But a lot of you guys don't. The way that you would do a change of base, because like I said, everything is in base 10, you would, in your calculator, hit the word log 7 and then divide it by log 6. Because everything is in log base 10. And you'd get a decimal. That's called the change of base formula. We'll talk about that more next week. No, it's not bad. It's not. But that, ladies and gents, that's it. I mean, the rest of this stuff is just going through rewriting. You're fine. You guys can rewrite and figure out what x is, that sort of a thing. The next few days, we're just going to be practicing rewriting log and exponential and evaluating. We're going to be practicing writing domain, range, horizontal, vertical asymptotes, and our intercepts. We're going to be practicing given a function, and we have to actually use our calculator and evaluate. We're going to be practicing when to use apert. Anybody remember? When do we use apert?
Like something compounded.
Compounded how?
Constantly.
Continuously, constantly. The other one is the other one. We're going to talk about interest and stuff. So we're going to just practice that the next few days to make sure we're ready for our quiz, which is Friday. And my birthday is Thursday. Okay, just make sure.